right, systems of equations. So what are systems of equations? They are a set of two or more equations that involve the same variables. So we're going to be looking at x's and y's. Both of our equations are going to have x's and y's. And we're going to try to figure out what the x and y is. So the solution, or the x and y of each of those equations, of the systems of equations, is the coordinate point at which the two lines meet. So we want to know the x and y of where the two lines meet. So we've got three types of solutions. This one right here, where we got both of these lines and they meet at this point, we've got one solution, and that will be that x and y point. If we've got two lines that are parallel, that means that they never meet, meaning we cannot have any solution. If they don't meet, we don't have a solution. And you can't tell, but this is two lines stacked on top of each other. So if they're the same line, then we call that infinite many solutions, because every single x and y is a solution. All right, our first step when we see these is to make sure that my equations are in slope-intercept form. Remember, that is y equals mx plus b. Ooh. So I have got two examples to remind you how to do that. We want y by itself. So our first step is to move the x. So it's positive 3, so we're going to subtract 3x on both sides. Minus y equals negative 3x plus 6. Remember, we can't combine those. And our second step is to divide what's by the y. This is a negative, remember, understood 1, so we're going to divide everything by negative 1. So y equals 3x minus 6. Move the x, divide by what's in front of the y. So here's another example, same steps. Move the x. There's nothing by the y, so that's the only step we have. That will be helpful moving forward to review. Remember that. All right, when we're given a graph, it's really easy to find where our points intersect and what our solution is. So we can see here our two equations. Here's where they meet, and we want to find the x and y. Remember, x comes first, so I'm looking at this point, and I'm going down to the x, and that is 1, positive 1. And then y comes second, so I'm going over to the y-axis second, and that is positive 2. Same thing again. Here's my point. Here's where they intersect. To the x-axis first, y-axis second. Those are at negative 4, negative 4. Here's where they intersect. X-axis first, and then y-axis at 4. So 1, 4. So remember, this is your x and y, x and y, x and y. This is your solution set. Whenever you see a systems of equation and you're asked for the solution, this is what it wants. It wants the x and y. You might just ask what's the x, so you would just put that number. All right, if we are given two equations, then we can put them in our graph. So these are the calculator steps. It looks a little long, but it's not as complicated as it seems. So we want to press the home screen, the home button, and scroll up here to where it says graph, or B. All right, and then we want to press menu 3, 1, And that brings us up to our functions. So I'm going to type in x plus 3 first, and then scroll down, and it graphs that one. And then I'm going to do, this says enter first equation, and press down. Enter in your second equation, 8x minus 4. Notice I'm only entering in after the equal sign. I'm not entering in that y equals. And then I'm pressing enter. All right, now what I need to do is I need to go to menu 6 and go down to this number 4, intersection. All right, now this little thing pops up. This is the only difficult part of this. We need to set a lower bound on the left-hand side anywhere on your graph, and then a upper bound. So anywhere on the left-hand side of your graph, as long as it is not right where these two equations meet. So I'm gonna just move, you can move this little dotted line wherever, and I'm gonna set it, and then I'm going to open it up, setting that next bound. Once you see the word intersection, you can stop and press. And then this is hard to see, but you see what popped up is that point where those intersect. So it looks like our graph's above, and then it says 1, 4. So we click to the left, and then we clicked to the right, and it gave us our intersection. So we can do that for all of these. Menu 3, 1. Enter in the first one, 3x minus 11, arrow down, 4x minus 17, enter. I'm going to menu 6, 4, and I'm going to come over here, click, and it says intersection. So I'm going to go ahead and click, and it shows me, oh, that one, very hard to see. Well, that just made it worse. There we go. And you can see here 6, 7. I just follow those same steps. All right, the only time when this gets tricky is this one isn't in our y equals, so I'm going to have to follow those steps from before. So 12x plus 2y equals negative 16. Move my x over negative 12. 2y equals negative 12x minus 16. Divide out by that number. Y equals negative 6x minus 8. So then that is what my first equation looks like. So I'm going to go ahead and do my calculator steps again. Delete. Menu 3, 1. Negative 6x minus 8. 2x is my second one. Enter. Menu 6, 4. Go to the left first. All over to intersection, and that says that is negative 1, negative 2. And that's it.